Future galactic collision. In about 4 billion years, the Milky Way will collide with the Andromeda galaxy, leading to the formation of a new galaxy, often referred to as Milkometa. This cosmic event will reshape the structure of both galaxies and create a celestial dance of stars. Galactic Archaeology. By studying the ages and compositions of stars in different regions, astronomers engage in galactic archaeology, unraveling the Milky Way's formation history. The exploration of star clusters and their chemical makeup provides insights into the conditions that led to the creation of our galaxy. Cosmic rays origin. Cosmic rays, high-energy particles, find their origins in various astrophysical processes within the Milky Way, including supernovae and active galactic nuclei. Understanding the source of these energetic particles contributes to our knowledge of the galactic environment. Galactic Evolution. Over its vast lifetime, the Milky Way has undergone continuous evolution, influenced by mergers, star formation, and the ebb and flow of its spiral arms. The intricate interplay of these factors shapes the galaxy's present state and future trajectory. Solar System's galactic orbit. The Sun and its planets follow an elliptical orbit around the galactic center, oscillating through the galactic plane over millions of years. This orbital motion exposes the solar system to different regions of the Milky Way, impacting its cosmic environment. 20 Galactic warp. Recent observations reveal that the Milky Way's disk exhibits a more prominent warp than previously thought, challenging existing models. This warp, possibly caused by interactions with neighboring galaxies, adds a layer of complexity to our understanding of galactic structure. Galactic age. The Milky Way is estimated to be around 13.6 billion years old, making it almost as old as the universe itself. Tracing the age of the galaxy provides a timeline of its formation, offering clues about the conditions present in the early universe. Star-forming regions. Within the spiral arms, regions like the Eagle Nebula and Orion Nebula showcase ongoing star formation, sculpting the galactic landscape. These stellar nurseries give birth to new generations of stars, enriching the Milky Way's stellar population. Globular clusters. The Milky Way hosts over 150 globular clusters, dense collections of stars, with the oldest ones dating back to the early universe. Studying these clusters provides a window into the galaxy's ancient past, offering insights into its initial stages of formation. 16 Disk warp. The Milky Way's disk is not perfectly flat, but rather exhibits a gentle warp, possibly influenced by interactions with nearby galaxies. This warping phenomenon, still under investigation, introduces intriguing questions about the dynamics of the galactic disk. 15 Central black hole. Sagittarius A is a supermassive black hole, with a mass equivalent to about 4 million suns, dominating the galactic center. This gravitational giant plays a central role in the dynamics of the Milky Way, affecting the orbits of nearby stars. Supernovae impact. Supernovae explosions release heavy elements into space, enriching the interstellar medium with elements crucial for the formation of planets and life. These explosive events contribute to the galactic chemical enrichment, shaping the composition of the Milky Way. Galactic dust lanes. Dust lanes obscure parts of the Milky Way, making it challenging to observe certain regions in visible light. Infrared observations help penetrate these dusty regions, unveiling hidden corners of the galaxy and providing a clearer picture of its structure. Milky Way's spiral arms. The Milky Way has multiple spiral arms, including the Perseus arm, Orion spur where the solar system is located, and the Sagittarius arm. These arms act as cosmic highways, guiding the motion of stars and gas within the galaxy. Gamma-ray bubbles. Discovered in 2010, Fermi bubbles are enormous structures emitting gamma-ray radiation, extending 25,000 light-years above and below the galactic center. The origin and nature of these bubbles are subjects of ongoing research, adding an element of mystery to the Milky Way's features. Oort cloud. Beyond the planets lies the Oort cloud, a region of icy bodies, and is the source of long-period comets that occasionally visit the inner solar system. This distant reservoir of comets preserves clues about the early conditions of the solar system and its interactions with the broader galactic environment. Galactic magnetism. Magnetic fields within the Milky Way play a crucial role in shaping the interstellar medium and influencing star formation processes. Understanding the intricate interplay between magnetic fields and cosmic gas provides key insights into the galactic ecosystem. Galactic cannibalism. The Milky Way has undergone mergers with smaller galaxies, with the remnants of these galactic meals still visible in streams of stars like the Sagittarius stream. These interactions, known as galactic cannibalism, leave lasting imprints on the structure and composition of our galaxy. Galactic bar. A bar-like structure extends across the Milky Way's center, with the Sun residing in one of the spiral arms influenced by this bar's gravitational forces. This galactic bar acts as a gravitational anchor, affecting the motion of stars and gas in the central regions of the Milky Way. Dark matter halo. Dark matter is thought to constitute about 90% of the Milky Way's total mass, forming a halo around the visible matter and influencing galactic structure. The presence of this invisible matter adds a layer of complexity to our understanding of the galactic gravitational landscape. Stellar population. The Milky Way is home to over 100 billion stars, classified into various populations. The majority are in the thin disk, with older stars found in the thick disk and the central bulge. This diverse stellar population reflects the galaxy's long and complex history of star formation. Galactic rotation. The solar system's orbital speed around the galactic center is approximately 828,000 kilometers per hour, covering the vast distance of about 230 million years for one complete orbit. This rapid motion through the Milky Way's spiral arms influences the solar system's journey through cosmic time. Galactic center. Sagittarius A is about 26,000 light-years away from Earth, and its presence is inferred from the orbits of nearby stars, revealing its immense mass. This supermassive black hole serves as the gravitational anchor for the entire galaxy, influencing the motion of stars and other celestial objects in its vicinity. Galactic size. With an estimated mass of 1.5 trillion solar masses, the Milky Way's gravity influences the motion of galaxies within its cosmic neighborhood. This substantial mass contributes to the galaxy's role in shaping the cosmic landscape and participating in the gravitational dance of galactic clusters. Spiral structure. The Milky Way's spiral arms are dynamic, with stars orbiting the galactic center at speeds ranging from 100 to 700 kilometers per second. This rotational speed creates density waves that influence star formation and the distribution of interstellar matter. The spiral structure is a defining feature of our galaxy, shaping its appearance and influencing the evolution of its stellar population.